From structure to semantics, hypergraph-based AR assembly guidance with LLM-mediated narration. Augmented reality offers immense potential for industrial assembly, but conventional systems have two main pain points: poor representation of the task's logic and high cognitive overload for the user. In this paper, we propose an integrated system that leverages a hypergraph representation and an LLM-mediated narration workflow as a solution to the dual challenges. First, we propose an assembly hypergraph to model the task. It uses hyperedges to capture higher-order relationships like subassemblies and encodes critical procedural logic, such as ordering constraints and prerequisites. We then use an A-star search algorithm to generate a structurally optimal baseline assembly path that satisfies all procedural dependencies. However, a machine-optimal path is often not intuitive for human users. To address this, we introduce an LLM-mediated narrative workflow to transform this path into more user-friendly guidance. In this workflow, an optimizer module reorders instructions to improve fluency, for instance, by minimizing tool changes. Then, a narrator module crafts the optimized sequence into clear, intuitive instructions, which are then effectively communicated to the user. To empirically evaluate our proposed LLM-mediated narration system and understand the distinct contributions of its representational and conveyance layers, we conducted a user study. Our study was guided by two primary research questions. First, for RQ1, we asked, does a hypergraph representation offer more effective guidance than a liaison graph? And second, for RQ2, does the LLM-mediated narration optimize the hypergraph-based guidance? To answer these questions, we designed a controlled laboratory experiment. 24 participants were tasked with assembling a complex, 25-part robotic gripper under our three counterbalanced conditions. Liaison graph. A baseline system that presented a linear sequence of steps derived from a simple liaison graph, representing the standard approach in many AR guidance systems. Hypergraph. An experimental condition using our hypergraph representation to provide structured, stage-aware guidance. The system enforced prerequisite checks but presented the raw structural progression without narrative optimization. LLM plus HG, our full proposed system, which used the LLM-mediated narration workflow to translate the hypergraph's structure into an ergonomically optimized and narratively coherent sequence of instructions. Turning to the results. On performance metrics, our LLM plus HG system significantly reduced total user errors, and was particularly effective in minimizing assembly method errors. In terms of efficiency, our system was also the most optimal, reducing the average completion time to under 827 seconds. Together, this data validates the dual advantages of our method in enhancing both operational accuracy and efficiency. To explore the cognitive mechanisms behind these performance gains, we analyzed users' visual attention. Eye tracking data shows that using the hypergraph alone increases the user's cognitive load in the assembly area. Our LLM system successfully addressed this. Through optimized guidance, it strategically shifted the user's visual focus from the complex product model area to the more efficient instruction area, which directly optimized the user's cognitive workflow. Finally, we evaluated the overall user experience. The data shows that our system significantly lowered the user's perceived cognitive load, NASA TLX, and achieved the highest usability score, SUS, approaching 80. Concurrently, the ARI scores confirm that our system received significantly higher ratings across key dimensions like usability and flow. Regarding technology acceptance, our LLM system scored highest in perceived usefulness and behavioral intention. These subjective evaluations consistently indicate that the LLM integrated system not only performs better but also creates the most preferred overall experience. Thank you for your watching.